Okay, number 5. We got quadrilateral gold, Gold, and the coordinates are listed on the diagram. And it says it's the base of a prism that goes straight up and down, a right prism, and the height of the prism is 13. We have to find the volume. So remember, volume of a prism or a cylinder is area of the base times the height of the prism. Well, we already know the height of the prism is 13, so that's going to go there. The base is that quadrilateral gold right there. Well, that's this quadrilateral, right? So we need the area of that weird boomerang shape. So it's on a graph, so you can bet good money that you're going to use slope triangles. Right there. Right here. So these slope triangles aren't too bad. The ones that get annoying are the part where it's concave. Right? So if I come straight down here, I've got that one. And then this one sort of bumps into the other slope triangle. Now normally we do a big rectangle minus these extra triangles, but I don't have a big rectangle. So to finish it off, I'm just going to do this right here. Now I've got a big rectangle. Okay, so I'm going to do a big rectangle minus not 4 extra triangles, but rather 4 extra triangles plus 1 square or rectangle down there. Okay, so we need 5 areas now. So let's go ahead and label the side lengths that we have here. So let's see, -6 to -3 across is 3, 8 to -4 is 12 down. This is going to be 8 across, 6 down. D to L, it goes from 3 to 2 for the y value, so it's just 1 unit down. This is a 1. And let's see, -1 to 5 would be 6 units across, so this is 6. 3 to D to G goes 3 to -4, so it's going to be 7 units here. Which actually means, since the whole thing is 7 and the top part is 1, the inside here is 6. And then across, it's 5 units across. So there we go. Okay, so now I've got all the lengths. This is 6 and 6 also, if you'd like to have those extra things there. So now let's figure out the different areas. So the area of the big rectangle, and by that I mean this, which is 11, by this, which is 12. So that's going to be 11 times 12, 132. Okay, then we need the areas of all the individual pieces. So area of triangle 1. Well, that's 1/2 base times height, so 1/2 3 times 12, which is 18. And then we got area of triangle 2, which is 1/2 8 times 6. So that's half of 48, that's 24. We got area of triangle 3. So that's going to be 1/2, let's see, where's triangle 3? Down here, 5 times 7. So that is going to be 17.5. And I got area of triangle 4. Let's see, where's 4? It's this tiny one right here. That's 1 by 6, so it's 1/2 1 times 6, which is just 3. And then we got the area of this square. Area of square 5. So that's just 6 times 6, 36. If I added up these 5 individual pieces, the sum of those areas is 98.5. So remember now, the whole rectangle is 132, and if I get rid of this triangle, this triangle, that triangle, this triangle, and that square, then I'm left with the boomerang shape. So I'm going to do 132 minus 98.5. So the area of gold is 132 minus 98.5, which is 33.5. So that's the base. That's the area of the base. Well, I got to multiply it, remember, so that's just this part. I have to multiply it by the height of the prism, which is 13. So the volume is going to be 33.5 times 13, which ends up being 435.5. Okay. Number 6 is a more annoying problem, I'd say. So the question is, you're going to revolve these 3 pieces around the x-axis. So when you spin them all the way around, you get a 3D shape. Now, part of it should be easy to picture. If you just reflect it across the axis, then these guys all turn into mirror images down below. So 3, 4 turns into 3, -4 down here, right there. And then this bar turns into that bar. But remember, it's actually a 3D shape, and when you spin something around, you get this circular shape here. So what we actually end up with is this cone shape to the left of the thing. And then I'm going to spin this segment around, and the easiest piece to find would be its mirror image down below. And this is also going to form a circular piece right there. So it's like a cylinder in the middle. And then if I spin around this kind of curvy quarter circle, I get this part down here. And then you can kind of see that the back end of this thing is a half sphere, right? It's half of a full sphere. So you can kind of think of this thing like it's a really short, fat pencil, where this side's the eraser, there's the main part of the pencil, and there's the part that you write with. So let's denote some stuff on here. Here, I'll use green here. That's the center of that base for the cone. And if I come straight up here, I know that the height of the cone is the y value, it's 4. And this distance right here, going across, also happens to be 4 because it's -1 to 3. So that's 4. So if you think about it, this piece right here, it's a cone with radius equaling 4. The height also equals 4. Now the height is this thing. You have to look at the cone sideways. Like if we looked at it normally, it would look like this. Right? It's just convenient that they're both 4. We don't know what the slant height is, but we don't know if we'll need that yet, so we'll come back to that. So the cylinder in the middle, well, its base is the same circle, so it also has a radius of 4. And this would be the cylinder's height right up here, and that's from 3 to 7, so that's 4 across. So the height also happens to be 4 here. And then if we look at the sphere part down at the end, this is a half sphere with radius equaling, well, if I just come up here straight up to the top, that's 4. And if you actually come this way, you'll notice that 7 to 11, that's also 4. So this is a sphere, in fact, or part of a sphere, so the radius is 4. Okay, so those are all the important features. Now, one of the things we need is the total area of this solid that looks like this, right? Now, the mistake that students make is they try to do total area of the cone plus total area of the cylinder plus total area of the half sphere. But if you think about it, that circle right there that's in between the two, that's not something you can touch. That's on the inside of the shape. So these circles aren't going to be things that we add in at the end. Okay, so let's look at total area. So total area is the surfaces you can touch. I can touch the outer part of the cone, but not the base of the cone. So that's going to be lateral area of the cone. And then I can touch the walls of the cylinder, but I can't touch the bases of the cylinder because they're stuck in the middle of the shape. So it's going to be just the walls of the cylinder, the lateral area of the cylinder. And then this thing over here on the right side, well, if I had a whole sphere and it was covered in paint, let's say, and then I chopped it, then I get a half sphere where that circle isn't considered part of the area that I had originally. So I can just do half the area of a sphere. Okay. So let's come up with these formulas here. So lateral area of a cone we know is half the perimeter of the base times the slant height. Perimeter of the base. Okay, well the perimeter of the base is 2 pi 2 pi 4. And then the slant height is this thing, so we got to calculate that. Well, that's 4 squared plus 4 squared equals slant height squared. So that's going to be, either you could do, or you could also do 45, 45, 90, but this comes out to root 32 equals the slant height. So this is a root 32 right here. And we are not going to keep this in exact form. So this all comes out to be 71.08613. So there's one piece. Then we need the lateral area of the cylinder. Lateral area of the cylinder is the area of, perimeter of the base times the height of the cylinder. So that's going to be 2 pi r times the height of the cylinder, which also happens to be 4 in this case. And that all comes out to be 100.53096. And then the half of the sphere, well, we know the formula for area of a sphere is 4 pi r squared, so 4 pi 4 squared. And that comes out to also be 100.53096. So then the total area is to add up those three things. So total area ends up being, when you add up all three of these things, 272.148. Okay, so now we need the volume. Let me shrink this down just a bit, because that takes up an awful lot of room. It's not shrinking. Let's see. Nope, can't shrink it for some reason. Maybe I can just shrink part of it. There we go. Let's see if I can shrink this too. One more try. Okay, so for some reason I can shrink part of it, but not all of it. Okay, so volume. Volume of the whole thing. Well, that's going to be the volume of the cone part, plus the volume of the cylinder part, plus the volume of the half sphere. So volume is volume of the cone, plus the volume of the cylinder, plus the volume of the half sphere. So we'll say half the volume of the sphere. So volume of a cone, that's 1/3 area of the base times the regular height of the cone. So that's 1/3 area of the base. The base is a circle, so it's pi r squared times the height, which we knew was 4. So then this ends up being 67.0206. Volume of the cylinder is area of the base times the height of the cylinder. Base is pi r squared, so pi 4 squared, times the height, which was 4 also. And that comes out to be 201.0619. And then volume of a sphere cut in half will be half of 4 pi r squared. So it's half of 4 pi 4 squared, which is actually half of the thing just before it. Oh, no, it's not. 4. Is it? Oh, I'm using the wrong formula here. Volume of a sphere, not area of a sphere. Half of 4/3 pi r cubed. My bad, sorry about that. So, not 6. 4/3 pi 4 cubed. And so if you work that out, you get 134.0413. And then we just add these guys together. So if you add them all together, you end up with 402.124. 402.124. Okay, I hope that helps a little bit. I realize that's a tough problem. There's a lot going on there. So if you don't understand it, make sure you take some time to ask me about it.